We insert a simple name and description for the tube sheet. We choose to intersect the tube sheet between the two flanges F1 and F2. We move on to the Design Data tab. We select Floating Tube Sheet and Type D configuration type. We move on to the Load Cases Input chapter. Here we choose to override the corrosion allowance values, setting them all to 0. It is reminded that in this heat exchanger, the materials of construction both for shell and tube side are carbon steel, therefore corrosion is applicable. But the tube sheet and tube bundle are copper alloys, therefore no corrosion is considered. Now we will input the modulus of elasticity. We select the TM3 copper alloys table and find C61400 for tube sheet material. Again, we select the TM3 table and find C4300 for tube material. We will demonstrate how to insert a thermal expansion coefficient, although not considered for this type of heat exchanger. We select the copper alloys table and choose the CXX material entry. We move on to the Data for Tube Sheet Input chapter. We fill in the rest of the data for the tube sheet and tube's layout. We should also mention that you can use the tube sheet calculator for some of this data, which is shown in detail in another tutorial. We choose Tube to Tube Sheet Joint for the type of weld. We select Joint Type I. We move on to the Flange Data Input chapter. We choose F2 for the channel side. And we can see that all the loads are calculated automatically. We move on to the Material Data Input chapter. We choose Table 1B and use the Advanced Search tab to find C61400. Here we see that the 020-025 record is for thickness between 50.8 and 127 millimetres. So we select the other record for thickness less than 50.8 millimetres. Now we will select the tube material. Tube sheets usually don't contain liquid, so we will not do anything on the component liquid chapter. You can find complete tube sheet calculations for every load case. Here we can see the tube sheet intersected between the two flanges.